Hello. Hello. Wow, I can't believe how big this venue is. It's crazy. I won't lie, I'm a little bit nervous, but I've got my Zelda shoes on, my Star Wars belt, my Transformer underpants. You don't need to know about that, but yeah. I did want to start this off by doing, like, has anyone seen, obviously you've seen The Simpsons, but like the Flamin' Homer where, who is it? Steve Tyler gets on stage and shouts, "Hello, St. Louis," and I can't do it. Like, I'm too scared to do it, but I just want to say hello to everyone. Woo! Yeah, I'm Paul Kinlan. I'm an engineer and developer advocate on the Chrome team, and I get to think a lot about the future of the mobile web. We've been working on a lot of technologies on the mobile web for a long time now, and I'm in this lucky position where I can start to think about, how all these pieces that are coming together come together. And the good thing about thinking about the future of the mobile web is that every presentation that you do, you start off with the beginning. There's a big bang moment of where something before the time is like no one knows about the change, and then after the time, everything's changed. It's like a zenith, an epoch, at that point where everything that's gone after changes the world. And obviously, we're going to talk about a couple of things in the future, or a couple of things that have happened relatively recently that have changed, like the future of mobile computing. But the thing that I think changed the world, but never got any credit because it never actually got built, was in 1822 when Charles Babbage built the difference engine. And I'm not sure if you've ever seen this, but if you do, it was in the Computer History Museum when I went. It's basically a 2-ton machine which calculates logarithms and kind of other tabular data. Now, the great thing was, he designed it in 1822, but the engineer, I say it's the great thing, it's a terrible thing, right? He designed it in 1822, but the engineering wasn't there to be able to build it at that time. And he never got to build it. And the other problem with it as well was if you wanted to build another set of kind of computational functionality, you had to build another 2-ton machine that would be designed to solve the problems that you needed to solve. It was a one-function machine, essentially. But Charles Babbage knew that this was a limitation and a problem that you'd have to deal with, and so he designed the analytical engine at the point. And the analytical engine, it was designed to solve and be a relatively general computing platform that would basically take punch cards and generalize programming. It had lots of the kind of common programming terms that we knew already today, like if statements and branching and looping and a bunch of other things. And Ada Lovelace at the time was one of the world's first programmers, if not the first programmer. And they basically decided to try and build a generalized computing platform. Henry Babbage decided to build a prototype, and the prototype didn't actually work quite right. It had rounding errors and off by one errors and a whole bunch of other things. So it wasn't really the change that we wanted to see in the world. But the interesting thing is it actually introduced this idea, for me at least, of removable storage, like an SD card for the time at that point via these punch cards. Now, you could just enter data in it. It wasn't a write-only. It wasn't a read-write medium. It was a write-only. You do it once, and then you push it through, and it's read. But you pushed it into the machine, and in theory, the calculation would happen once it ran the program. And at the end, you would get the output, the thing that it created. The calculation that it came out on a very formal, a very kind of basic printer at the time. Now, if you jump forward another 100 years, we're still using punch cards, right? We have these rooms and these machines that are the size of these massive rooms where you would design and create a program, take it to the machine, you could post it via the postal service. You could put it in, someone would put it into the machine, it would go off and, I say load balance, that's the wrong way of saying it. But it would timeshare, essentially, at that point. At some point in the future, you would get your data back if the program ran successfully, and then you'd be able to do it. The interesting thing, for me at least anyway, is these machines, they took away, not going to say that didn't take away a whole lot of jobs, but they optimized the process of very repetitive tasks and changed the industry at the time. Very machine intensive and very kind of quite interesting. But the point is, it was the start of the computing generation at that point. And if you jump forward again another 20 years, we've got rid of the punch cards, and we're at this point where we have these home computers where you can take these disks, these cassettes, put them into your machine, and then start to play a game. And yes, it took a long time for your applications and your games to load up, but the important thing was you could go to a store, a shop, buy a game, take it home, load it up, and play it. It was kind of a very transformative point in the computing industry. Then you move forward again a little bit further, and this idea of floppy disks, obviously there's many different form factors of floppy disks. But the idea behind this was you could take data, write it to a disk, take it from school to your home, do your homework, save data, transfer programs, and a whole bunch of other things, again, on a disk. I mean, they were incredibly limited in the terms of like storage capacity, but the fact that you could transport all the data around, it was, again, game-changing for a lot of people. Now, the problem was, like, if anyone ever had to install Windows 95, or Office, using 30 different disks, you recognize how long it took to actually do anything with the data on those machines. Which is why when we came up with the idea, well, obviously the idea of CDs, CDs invented in the late 80s, didn't come into kind of general use until the mid-90s. But again, they transformed the way that we actually thought about computing. We could access movies, encyclopedias. Windows 95 would install in an hour, at that point. Like, it was quite interesting. Like, when you think about the next generation after that, again, it was like Blu-rays. It went from 650 megabytes worth of data to like 5 gigabytes or 50 gigabytes worth of data that you could store. The amount of data that we could transfer on these devices was absolutely amazing. But the problem was, at least in the kind of the more common era, that the installation process and management of these things was incredibly cumbersome. It was really hard to actually kind of, you'd get an application, and then you'd install it, and if you did do it for your parents, your parents would ask you to kind of make sure that the machine worked well, and like, that's one side of it. But if you're in the enterprise, you'd have to have entire teams built around this idea of deploying software in the enterprise. You'd have to have user acceptance testing. Obviously, you have to have integration testing, but you have to make sure it works in the environment it's going to run on. And you jump forward again a little bit, we had this idea of the web. Like, this is where things, for me, start to change dramatically. You enter a single URL, and then you get access to anything that can be accessed by the URL. We got things like Hotmail, we got things like Gmail, Google Maps, and all those types of applications as well. And then when you thought about things like the enterprise, that was actually quite interesting as well. You had these massively hosted multi-tenancy systems that they had no install. They had incremental download as you navigated through the pages, and in theory, they were sandboxed. So one application couldn't kind of meddle with the data that was held in another application, unless there was like a well-defined API bridge between the two. So for me, at least, I just realized if I stand here, I can't, it doesn't reach the thing. I'll stand here, it's fine. But the idea behind it was like the web, we knew this at the time, it was far less capable than the native platforms at the time. Didn't have access to the devices or anything on the actual user's machine, but the delivery model was massively better. It was a lot more efficient, a lot more optimized. You basically could build anything you want and give it to a user just by entering a URL. And then, I kind of like to think the term as like the original kind of part of the web, where we didn't have Ajax at the point. It was like peak CGI. So you got to the point where you would, you'd enter some data into a form, submit it, it would do some processing on the server and respond back. Then we got this concept Ajax. Like, Ajax you could create applications, or Web 2.0, or whatever you want to call it. You could create applications which felt as rich as a native application on the desktop, but they were still delivered by mobile, delivered by just going to the URL. And that was quite interesting for me, because at every single phase in these computing revolutions, some form of friction was removed. It could have been things like, excuse me, it could have been the amount of data that you could transfer and put on so you could create bigger and more interesting applications, or it could have been the method and model of actually delivering the data to the user that had changed fundamentally. And specifically, and this is one of the things I want to try and focus on today, is this idea of like distribution, right? Distribution was one of the hardest problems in software. And I'll talk about this a little bit later on a bit further. But the idea behind distribution, at one point you had to build the machine yourself and put the code on the machine yourself to get an application working, to this point in the future where now we just enter a URL in, and we get to the point where we can just go and visit the page and actually start interacting with the content. And I think that's incredibly powerful, right? Like, that's a massive set of step changes since the dawn of computing, I think in 1822, to the point that we are right now. But the problem for me is that all of these devices and all these kind of sites and programs and apps have been designed in a desktop world. They've been designed for, at one point it was 640 by 480 screens, then up to 1024 by 768. And every time that we kind of got like a general increase in screen size, everyone like, oh my God, I have to redesign my site, and it's terrible, and it was crazy. I kind of think that this is the mobile-lithic era, right? It's like, once mobile came along, like, everything changed. And before that, we were in this kind of nice, happy world of desktop. And it kind of, in some point in the near future, it's probably going to look quite arcane when we go back to how we used to build software for at least in the web. The the thing I want to try and get across as well is that the rate of change is increasing as well. For a long time, we just had punch cards and the ability to actually push data into a computer that way. Then we had disks, and then we had CDs, and then DVDs, and then the web came along, and the web is still there, and it's a medium we still use to distribute things. But in the mobile era, there's a lot more things coming along. We all know about the App Store, right? But if you look at the App Store as a distribution model, it's great. It solves a lot of problems. But there's also a lot of different things coming along the lines as well with chat applications as well. So if you look at things like Facebook are doing and other platforms, they're giving you more and more ways on mobile to distribute software. And I'm going to talk about a little bit more about that in a bit. But this is the point, like June 29th for me is when, before that, we had mobile, we had WAP pages and a bunch of other things. It was kind of a terrible web on mobile. The iPhone came along, and it was powered only by mobile, only by the web at that point. And they introduced a whole bunch of new APIs for you to be able to build these great new kind of like web-like applications on their platform. And we'll talk a bit more about how they changed their mind in a minute. But this point, before that, we didn't have the full web. They sold the phone on the idea that you could access the full web, desktop websites, the full web on this small mobile phone device. I think that's an incredible thing. And I also kind of look, I've made this graph up. It's not based on any real data at the moment at all. So I was like, should I caveat this or not? Yeah, I probably need to tell everyone it's a fake graph at this point. But I wanted to try and get across the point is like distribution and the cost of distribution, the difficulty of distribution have been decreasing for a long, long time. We're at a point in the world where distribution has never been easier than it was before, but there are still a number of problems that need to be solved still. And if you look at the native space, and this is a quote from Gabor, and it's still broadly relevant, but he says, in a consumer mobile app, every step you make, user perform before they get value out of your application, you lose 20% of your users. And that applies to the web. It applies to a lot of other platforms when you look at the data. But the way I kind of like to put because I like the web, right? And I don't like native applications, and then we have to go through these stores. So I'm a little bit biased in this sense. But when you look at the number of steps that you want to go when you want to install something like an air horn application, right? I've made an air horn web app as well, which I'll encourage you all to go to in a minute. But the idea is that you go to the store, you find your application, you load it up, you find it in the store, you click install, you wait for it to download, you accept any permissions if there is any, then you wait for it to download, and then you might use it once it's on your home screen. And when you look at the numbers, it's like if you're losing 20% of your kind of maximum theoretical target set of users when you start from the beginning, well, that's actually pretty bad, right? Because you're losing 20%. You end up with less than a third of your overall users at the end. And again, these aren't actual figures. This is just an extrapolation of the actual steps. But when you think about something like the web, again, you just have a URL, the user goes to it, and then they basically start using the application at that point. And the comparison, for me, is quite stark. Like, we have problems on the web where we can't make our applications installed. Well, we can. I'll talk about that later. But the idea is that our web applications and our websites, they're not like traditional native applications. They don't feel like they're supposed to be native. But the thing is, if you want users to use your experience, you give them the URL, you'll still lose some users out of your maximum theoretical target, but you'll have a lot more users at the end. And when you think about it as a graph, I think it's quite interesting, right? You can see the difference. Like, I know there's a lot of worst-case scenarios as well in terms of native applications, and I'm railing on native applications a little bit at the moment. But the thing that I want to question, and I question for everyone else, is that native platforms know that there is a distribution problem. If you're the App Store or you're the Android Marketplace, Android Play Store, oh my God, I can't remember what it's called. You know that this is a problem, and you want to optimize that for every single user, right? You want to make sure users are downloading your applications. So the question isn't really what happens when native solves this, because if you look at what Android is doing, they're actually trying to solve this right now. And I think this is interesting because Android Instant Apps, they're, in theory, a threat to the web at some point because you go to URL, and if the site owner wants you to download an app, they can just say, download the app instead. Like, I think the web has got a tremendous advantage because we have the ability to progressively render the experience. Whereas with these type of experience, you have to download the entire package before you start to use it, and I think there's a problem there. But it's interesting, right? Because native applications are trying to take all the best bits from the web, and what we're going to talk about today is how we can take on the web all the best bits from native, and there's going to be a crossover at some point where doesn't probably really matter what you decide to build it in. It's just everything's going to be accessible via the web. So web development itself might change. But this is where it gets, right? It's like if you're a developer and what you choose to deploy on, the thing that you end up competing on is engagement, right? It's like these steps, like once the users open the application to doing and performing the task, is like it's all user experience at that point. And I'm not going to talk about user experience today because I'm not a user experience person. I'm all about APIs. So I think that's interesting, right? As a potential future for the web, where the web is going, I don't quite know at the moment. I think there are potentially a lot of threats out there. But the one thing I do want to talk about briefly is like the idea with where the web is at the moment in terms of users, right? Like we all know about kind of the 8-second piece of data. Like the average website takes at least 8 seconds to load or before anything is on the screen. But we know that 40% of users abandon a website if it takes more than 3 seconds to load. We have problems with our kind of ecosystem and industry where we're kind of happy with a slow experience. And I think this is important, especially on mobile, because, and I'm going to talk about India in a minute, but I want to kind of concentrate on some of the US side of things, where the number of US households that are actually just cellular only is about 20% of households, apparently. And I've got some data which I haven't actually put the link on for, which I'll share out later. But that's doubled since 2013, and it's going to keep increasing and increasing. More and more people are going to go mobile. And you think, great, because everyone's going to be on 4G. Well, I'm in the US at the moment. I'm on roaming. It's 2G only for me at the moment, unfortunately. A lot of people don't have great connections, even if they're going to go mobile only. When you think about the bigger picture, the context of like the rest of the world, like 60% of the rest of the world who are mobile connected are only on 2G. So kind of thinking about how to optimize performance and the way we go, like for performance at least, is going to be like the next big thing that we're going to do. Now, yes, like technology is improving, but even with the kind of predictions that they got now, it's like 2020, you're still going to have 20% of people on a 2G-based connection. But this is important for me because I've been out to India and Indonesia and like a lot of places recently, and I've spoken to a lot of users and a lot of developers about what they need to target and how they're trying to build software on the web. And it's kind of interesting because like America and Europe and the UK, like we've got the web and we've got computing at this point. Like near enough everyone has got a computer. And if you look at the current estimates, I think it's about 286 million people in the US have got a mobile internet connection. India is nearly, it's not quite double, it's like 480 million people have got mobile connectivity at the moment. China is like more combined than anyone else, and like 750 million people have got like a mobile internet connectivity. And I think that's incredible, really. Like China's, what do I say about China? It's often its own little place. The web in China is very different to the web that we know. But if you go to India, the web that they experience in India is very much like the web that we experience, at least. But for me, like they're big markets, right? But the growth is still there. From 2014 to 2015, like there was 100 million people in India alone joined the web, mobile in particular, because everyone is like mobile first, right? Some people's first computing devices are mobile devices. That's 10 times the growth of China, more than 100 times the potential growth in any of the other countries that we've got. And the way I look at it is like a third of the US have basically come online just in India alone. For me, it's like in the UK, we have like 60, 70 million people. Like the size of the UK every single year is coming online in India. And I think that's crazy because they're either going to choose this point where they want applications or they want like web experiences. And the growth in the ecosystem is absolutely huge. Like I said, there's 65% of India's overall ecosystem is still not online yet, so there's still huge potentials for growth. Now, the interesting thing about them is like when you compare things like, this is the 6P at the time, 3 gig of RAM, 120 gigabytes of storage. Like one of the most popular devices launched last year was the Samsung J1. It's like 4 gigabytes of storage and 512 megabytes of RAM. These types of like poor devices to some extent, you look at things like the Moto G as well. Like these constrained devices, once you've done your basic install of a couple of applications, you can't update them anymore. You can't download any more applications. Like the device constraints that a lot of people have in the world materially impact the way that they can use native experiences. And this is why I think the web is actually kind of really good for a lot of people, is because like it's not really like you go off and download and install stuff. You just kind of passively consume the experiences as you go through. And yes, we'll cache data and we'll store it offline on the user's device, but you don't have to worry about these massive downloads. And I think the web has got an interesting value proposition. But it's not just about things like devices as well. We said that before, obviously, 40% of people drop off a site if it takes more than 3 seconds to load. There are a lot of other pieces of data that suggest that A 1-second delay is a 11% fewer page views, 16% decrease in customer satisfaction. But like we know this, but like the thing for me is when you think about the data, like when you're in the UK, for instance, you'll use Wi-Fi a lot of times. Like when you go to India and a lot of other places, people are just on cellular pretty much all the time. And cellular data costs a lot of money, right? When you think about it, like if you do some basic calculations, and India's minimum wage varies across the country and the type of job that you're on, but roughly 17 hours will, like a minimum wage work will get you 500 megabytes worth of data. And I think that's incredible because people are buying these devices and they get value out of using the applications and the websites on them as well. But when you think about the size of the web and like what we're doing to build sites, I think that's quite interesting because we have, at this point, 1 hour's worth of Indian minimum wage work is a roughly 15 page loads, right? And if you think about the number of pages that you potentially visited today on your mobile device, like that's pretty crazy, right? It's relatively constrained what people can do. So I do want to highlight and emphasize the fact that performance is everything, whether you're in the US, whether you're in the UK, or whether you're kind of targeting, I don't say emerging markets, but like the next billion users, as we tend to call it. And it's not just kind of download size, it also kind of covers, because the devices can be relatively constrained, user interactions, scrolling, the whole kind of performance piece. And we're not doing a very good job on the web industry as a whole at actually catering for that. There is one other area that I want to briefly talk about, and it's this whole idea I've been trying to think about the rise of the meta platforms. And what this is we have iOS, we have Android as the two mobile platforms. Desktop, that's fine. You can build applications and deploy them on them. We know that, that's cool. But the web sits across everything, right? The web is across all these different platforms, and we can deploy to it, and it's great because that means everyone can access that. And this is like the traditional view that we all have of the meta platforms. The web is the meta platform. But when you look at mobile, in particular, you start to see things like messaging applications. Facebook, Line, Kakao, WeChat. There's whole bunches of messaging applications that have got hundreds of millions, if not billions, of users. Like Facebook, billions of daily active users, or billions? A billion daily active users, or whatever the latest stats were. Like user time and user attention is in these applications like pretty much all the time. And they're all starting to kind of scope out, right? So they're sitting there going, we want to own the content experience and we want to own the application experience. We have all these users, we can do a lot of things with them. And if you look at just the pure content side, we've got iOS, Apple News. I don't think it's particularly successful. But you've got things like instant articles. Facebook are pushing that like crazy. You've got Kakao, you've got WeChat. WeChat again. Like when you think about China, sometimes you can go and look at WeChat and the entire web is inside WeChat and people are building experiences in there. But the thing that people are doing, and the reason why people are actually, or say people, these companies are actually talking about these experiences and these platforms, is because performance is the key selling point. Like if it's that 8-second page load, and you see it in all the advertising for these platforms, is it takes 8 seconds to load the average web page on mobile. That is a terrible experience. We can load it in 100 milliseconds. That's what all these platforms are selling. I think it's a little bit more kind of complex than that. I think, if you're, Google probably do this as well, right? But like Facebook or if you're any of these other platforms, like you want to keep the person or the user inside your platform because you already have the user's attention. Send them outside into this kind of open, wide world of the web, I suppose. You probably don't want them to do that. So you want to kind of think about how you can keep the content and those experiences for as long as possible on your platform. And then when you look at the web, we don't have an extra kind of thing that focuses just purely on performance. To kind of combat those other kind of platforms. Now, I don't want to kind of sound like it's a marketing thing. There is like kind of, how to talk about this is an interesting one. Is like Google has made this project called AMP, and AMP is quite interesting because the theory is it's an open source project. And it just so happens that Google implement AMP inside the news part of search. But the idea is like Twitter used this as well, but like it's a relatively constrained platform of known performance problems that are solved and got out of the way using custom elements and a whole bunch of other things, which will allow you to build a fast experience. The goal of AMP is to build fast experiences. And they do that by like restricting and constraining the platform about what you can deploy. As one option, there's a lot of other kind of options out there, but even as a normal developer, you shouldn't have to worry about these technologies. You should just be focusing on the idea of performance, especially in the content space. And now if you look at these other platforms, again, like Facebook, Line, the web is the next one as well. but like they all want to be like the next browser, right? If you think about these applications, specifically the messaging applications, they want you in the experience all the time and kind of consuming those services. Now, I think that's interesting because when you look at the API space that they're offering, they're starting to introduce things like messenger bots because it's lightweight interactions of communicating with a service. I think it's incredibly powerful. But when you look at the way that they're building these things, they can't go off and deploy brand new applications. They can't go and deploy brand new applications out, via native code. They're using kind of all the web technologies around to support their kind of platforms because, on iOS and Android, you can update JavaScript code, you can update kind of web-based code dynamically as you want, whenever you want, and not have to go through any approvals and reviews. But the interesting thing is that because you own the web view and you're using that experience, you can start to introduce new APIs which are available to developers. So a lot of the platforms are thinking about identity, like integrated identity, integrated payments, a lot of other integrated APIs that in some cases might not make sense on the web, but make a lot of sense to users. They've got a web, which is not really the web. And I don't know whether that is a good thing or a bad thing, but the point is, again, the reach and distribution is phenomenal. Phenomenal? I can't say the word. It's terrible. But that is kind of, I talked about the history, and I talked about the kind of the current way of the world, I think, at the moment. So what is the future? I mean, that's the whole point of this talk, the future of the mobile web. Well, I've come up with a relatively rough idea, I think it is. It's like this whole idea of a game. I bought an iPad Pro just so I could draw graphics, and this is the only graphic that I can actually do with it. It's terrible, isn't it? Like everyone, like my friend Paul Lewis, like he does these beautiful graphics and he's got like animated characters in and stuff, and I just come out with these stupid drawings. Anyway, so the idea about the web, right? And if you look at the browser vendors and what they're trying to do, they have a rough plan of like a plan of attack, and like it's in kind of 4 areas. The first is to try and match native on features, not directly on features. Like you don't like. Well, I'm going to say you don't want to have USB on the web. We're going to have USB on the web, but it's kind of the web following the same security model. It's not just blind access to all these APIs. But we want to make sure that there is no reason why someone would deploy to native over the web, because for a long time, that is what it was. Is like, the web can't do X, that's why I need to have a native application. So we want to make sure that the web platform is capable. We want to focus on performance, and then we want to also increase engagement. And I'm going to talk briefly about progressive web apps in that idea of increasing engagement. But the first thing is, like, this is not anything that you can do, really, unless you're a browser vendor, is that everyone needs to get their mess together, right? Is that we've spent a long time building different features and different capabilities. And it's fine, right, inside browsers where you might introduce one big API, like Web Bluetooth, right? Web Bluetooth is in Chrome as an experiment at this point. It's in Chrome. But you know it's in Chrome, and you can choose to build on the web or not. But when you get to something like Flexbox, which is supposed to be supported across every single browser, you have to deal with the fact that there's 2 different versions of it, that there's a UC browser version of it, which renders differently to everything else. Like, there's just lots of little errors in between them as well, lots of different implementation issues. It's just a massive nightmare to deploy just basic web applications across the entirety of the web. And there's a lot of browser vendors like Microsoft, and if you speak to Rick Byers from the Chrome team, he's got this predictability plan. The idea behind predictability is make it easier for developers to build great websites and applications. So browser vendors need to do this, and you're going to see more and more kind of things coming through of just consistency and fixing things. On the idea of matching native, again, this is another, I didn't caveat this graph. This is a completely made-up graph, again. But the point I wanted to get across was when the iPhone launched, it was web-only, right? They introduced a huge amount of APIs which were mobile-centric, app cache, local storage, media queries, huge amounts of different APIs which made sense for the mobile web versus just the pure desktop web. There was a lot of vision and forethought that went into making a good mobile web experience. But they kind of realized that developers didn't really want to deploy native applications on the web at this point. They wanted native experiences, and they wanted a way to distribute it. And we know the story, right? The minute that Apple introduced like their platform and their app store, boom, right, everything changed completely, right? It's like the web just did not keep up. You got more access to APIs, sensors, huge amounts of different application APIs just on the native platforms. And it took a long time, right? I blame Android for a lot of this as well to some extent. Is like, Android had a really crappy browser for like the Android browser for such a long time, which never got many updates at all. we just stagnated for a long time. It wasn't until like the industry as a whole started to get together and say, we just need to improve. We need to offer more experiences to users. Like, what are their problems that they have? And we'll cover them in a minute. But there are a lot of different APIs that are available on the web, right? I mean, when you look at the, I'd say this, when you look at the number of mobile-centric APIs that came around, I'll just list some of them now. You've got things like geolocation, right? It's user permission required, right? You can't give access to anyone's location just whenever you want. It's HTTPS only now in Chrome and Firefox, at least. You know, we've got things like the camera, right, where it works across. Again, you need a user gesture to access the camera, and you can access it inline inside your application, and it falls back to iOS, but it uses the native camera at that point. We get things like the microphone, right? You can record audio, again, inline because we've got access to the microphone and the camera and a whole bunch of other things. But again, it's locked behind a whole set of permissions, HTTPS only. But again, if you're on iOS, you can still use the native application to record data and put it into your application. We have things like battery status, so you can understand. I don't really like this API. It makes no sense. Like, I don't send an XML HTTP request when it's on 5% battery, maybe. I don't know. But the idea is, like, you know, you've got this access to hardware and more information about the device that we never had before. We've got permissions, so you can offer streamlined experiences. You can give the user confidence that they can disable all the permissions that they've granted. If they've given you geolocation, for instance, and they don't want to give it to you anymore, they don't have to go crawling through all the Chrome menus to go and get it. You've just accessed it through the permissions API. You can understand the network information. So is the user on a cellular connection? Are they on a Wi-Fi connection? You can also get the maximum theoretical speed of the connection as well. And this came from when we were in India, and a lot of Indian developers were saying, if we understand the maximum theoretical connection speed, we can optimize the user experience. I've not seen anyone actually use it just yet, but the data is there, and you're able to use it to build experiences. And this is an incredibly boring piece, right? Autofill. But by implementing the correct tags and metadata on your input fields, you can vastly improve the performance of your forms. Like, the web is mostly about forms, right? You're entering data, trying to complete a purchase, and everyone hates typing on the keyboard. We can solve that, you know, across multiple browsers now just by providing the correct metadata inside the page. But when you think about what you can do to enter data into a form, like, obviously everyone normally has to sign in and sign up to a service and then log in time and time again. The idea behind the credential management API is like, well, you can synchronize, like, the user logs in, you can synchronize that credentials across all the devices that they're connected to, so that when they go from machine to machine or come back again, they just press one button and they're logged straight in, because the underlying operating system, Chrome in this case, or the different browsers, they go, okay, it's great, I can do a whole bunch of stuff. I know the user's logged in, I'll log them back in. And then, if you follow on from the credential management side of things, you've got things like the payments API. You probably all know about Apple Pay, and it's a great introduction to the web, the fact that you can streamline the payment experience. No one likes entering data into forms, and Apple Pay is a really smooth experience on mobile. But there is also an open version of that, the Payment Request API, which was just released in Chrome, and there are a number of other browser vendors are also working on it. Microsoft are working on it as well. Now, the idea behind this is that you can integrate with, like, platform-specific payment providers, like Android Pay in this case. That's a bit of advertising, I suppose, isn't it? Android Pay. But if you're on Samsung, maybe you could integrate into a Samsung thing or whatever. It's down to the application, the operating system, to provide that resolution of services. But it can also integrate into your existing checkout flows. If you've got Stripe, you can provide all the data straight through to Stripe just by one tap on the screen from the user. And the really interesting thing is, like, if you've already got the credit card information, you probably don't want this API. But if you're trying to onboard a user through a guest checkout experience, like, you can combine that with the credential management API to automatically create a user account, which is then synchronized across a whole bunch of devices. I think that's quite powerful. And there's a lot of things to go on in this space. And I'm sorry for talking really fast. Sorry. We have the idea of push notifications. This is one of the biggest features that people requested for on why they were building for native. You know, the idea that you can send a notification to a user about an important action on the page, even when the browser is closed. Native applications can do this for a long time. Now, the great thing is, again, it's gated on a user permission. We just don't get free access to send notifications willy-nilly. We can just, you know, send it straight through. You have to, like, once they have to accept it, and then we can send the permissions. We have this idea, offline support as well. You know, obviously we've got things like App Cache. Service Worker I'm going to talk about Service Worker a bit more. It's a major API that's come through that allows you to have more fine-grained control over the offline experiences. Installability, if you use the application manifest, you can make sure, like you as a web developer can control how your website, your web application looks and feels when the user chooses to install it on the user's homepage. Now, on the user's home screen. And I think that's incredibly important, right? Like, rather than just kind of bookmark a page to the home screen, you can just say, well, the demo is working. Great. The demo didn't look like it was working. But you can add it to the home screen, and it launches, and you get this kind of full-screen application-like experience. I think that's incredibly powerful when you think about the future of the web, especially when you're trying to build more application-like experiences on the web. Now we get into the more experimental place. Like the browser vendors want to make sure that you can have access to pretty much everything the user wants to have access. Again, all gated by user permissions. It's not just kind of blind, discover all the devices around me and connect to them. You have to be very specific. But you can just connect to a Bluetooth device, start controlling it. This is Sphero's BB8, the top corner there. They're just JavaScript commands and commands being sent over JavaScript to the device. Then there's things like the generic sensor API, which is not in Chrome just yet. But if you speak to some of the people at Intel, they're doing a lot of work on this. And he sent me the demo for it yesterday. But the idea is that you get raw, we used to build high-level APIs to get access to all these sensors, but the idea is that you get a low-level set of primitives to access and connect to any set of sensors, and then you can build higher-level abstractions on that, so you don't have to wait for the platform to keep, for the browser vendors to keep kind of connecting, updating their platforms, updating their browser, just to add new hardware in. Now, things like magnetometer and accelerometer, those type of things, but then you can create fused sensors, so you can create a compass off combining the magnetometer and the accelerometer. Quite powerful, especially if you want hardware access. Web USB, the important thing to say about Web USB is it's not just open to every single type of device that you want to connect to. You can't connect to the user's Web USB camera. The hardware provider has to make the website that can access the device, and it has to be encoded on the device that the URL. It's really complex, but the idea is that you can't just access anything that you want. If you wanted to have some hardware, you as the hardware developer would control the website that only has access to that piece of hardware. It's relatively complex, and they want a lot more feedback on this place. Something that's very close to my heart, because I was working on web intents for a long time, is native sharing. The idea is that you can be on a web page, share out to a native application. It's really hard to do at the moment, especially on other platforms. But that's not the only thing, right? That's good that you can share out to a native app, but what about a native application when you do a share action? You want your web application, if you're Twitter and you're only on the web, you want your website to be in that list of things that you can share to from native. And the navigator.sharing API is pretty powerful, right? Because you can say, I want to share to a native application. I want my web application to be shared to another web application. I want my web application to be in the list of things that a native application would share to. I think it's incredibly powerful. And then there's things like WebVR, right? WebVR in this is, that was ages ago. 3G and 3GS is brilliant, right? But the idea behind WebVR is, it's VR on the web, right? But the thing that's interesting for me is that this is coming out and being developed to kind of come out when all the other mobile platforms are ready for VR, right? It's not like we're going to have to wait 1, maybe 2 years before we have a generalized web-capable VR system. It's nearly ready, and it's at that point of where, when native gets it, the web gets it at the same time. But the web will be able to do so much more because we can provide web-like experiences. You go to a website and you can flick on VR mode if you wanted, if the user wanted it that way. I don't know how successful it's going to be. It might not be that successful because you need a big piece of hardware in your face to actually sort this thing out, but it's kind of interesting. But the interesting thing for me, at least, is that, as you can see, the web has been catching up, right? We've been getting more and more and more kind of closer to the native experiences. We technically still got a really long way to go, but that's the intent of some of the kind of the platform developers. But the question is, and everyone's saying, that's just a list of APIs, right? It's not a real strategy. And you're right. And also, they don't work in other browsers, right? But every browser vendor knows that they can ship these features, but you get the big features, which you have to choose to implement or not. But then you have this whole idea of the predictability, making it easy for developers to actually build experiences that work across platform quite easily, and then progressively enhance as you go on. I'm not going to concentrate too much on performance. I'm going to be really fast through it. But the idea behind performance, has anyone heard of Rail? 1, 2. You've all heard of Rail now. But the idea behind Rail, at least, it's a very user-centric model for thinking of performance. The idea here is that you should respond to user gestures within 100 milliseconds. Animations, 60 frames a second. You shouldn't do anything that blocks the renderer from actually maintaining 60 millisecond frames. Idle time is interesting, right? Because it's really hard to think about idle time. But a lot of people put in work which takes a long time to do. It takes more than 50 milliseconds. And if the user clicks a button, and then the user interface doesn't respond because it's doing some work, or the browser can't respond in time, then it feels laggy. So the idea is make sure you can chunk your work up and the complex computation either into something like a web worker or into 50 millisecond chunks. And then focus on, say, a load time of 1 second. It's not really a full load time of 1 second. That's incredibly hard to achieve. But the idea is that for the user, something is visible and something is interactable within 1 second. The application doesn't have to be completely loaded. And I'd encourage you to look at Paul Lewis's work on progressive rendering, and especially bootstrapping. I know a lot of developers use frameworks, and we see a lot of applications where they'll pull the framework in, and it'll take a long time for the framework to boot up. And then, it's like maybe it's a lot of time just in JavaScript, kind of initializing the framework system and then loading up the rest of the page and then data binding before anything is visible on the page. And there's nothing wrong with using frameworks. So it makes everyone deliver more effective software more quickly with less bugs. But you have to think more tactically about how you deploy your applications at that point. And I can talk about APIs for a long time. There are a couple of different APIs that come into the web which are just focused on helping you make more performant applications. Intersection Observer, when a DOM element comes into the screen, you'll get a notification. That's great. And things like request idle callback. If you want to chunk your work into 50 milliseconds, request idle callback will say, hey, we think there's a 50 millisecond break that you can actually start to execute some stuff in. And I know a number of bigger companies are starting to use that API at the moment. So increasing engagement, right? That's probably the biggest piece that we need. We've got a whole set of APIs. That's great. And then we want to focus on performance. But the biggest bit is just about providing good experiences to users. And when we ask developers, what do you want? This was in 2013 at the point. What do you want to be able to build a compelling next generation, or not even a compelling next generation experience, but build a compelling experience that would mean that you don't have to go to native. And the order that everything came back was access and installability to the home screen, push notifications, and then good offline support. There were a couple of other things that came back off the back. But it's actually relatively hard. Those APIs exist now, and we can tell developers about it. But it's really quite hard to think about how you package them all up into a framework, or at least a way of thinking about how you combine them all together. So we thought of this idea called progressive web applications. I'm going to talk briefly about it at the moment. But the start of it was in June of 2015. Alex Russell and Francis Berryman, they started thinking about how you can deliver these applications, these new types of applications with all these new APIs. And the idea was you don't want to just offer an install button and make it kind of app-like straight away, because the user might not be engaged. But if the user is engaged, the more they use the experience, the more app-like it becomes. So if you use the site and you go around and navigate around the site, at some point it's hey, you probably want this on your home screen. Do you want to install it? It doesn't do it straight away. It does it after maybe 3 visits to the site. Or it's hey, you're really engaged. We do push notifications. Do you want push notifications? So rather than trying to get access to all these features straight away, the more the user used the site, the more progressively it would become installed on the device. Now, the idea is progressive is a really overloaded term. We encourage progressive enhancement as well, because we know the APIs aren't available on all platforms. But they are kind of you can build great web applications just by changing the way you think about building experiences. But the big question that everyone has is what makes a progressive web app? And it was only last week that Alex actually posted this, because we get the question quite a lot, because it's relatively nebulous, right? It's what is Web 2.0, or what is AJAX? AJAX was XML HTTP requests and XML JSON and a bunch of asynchronicity and a bunch of other APIs, right? An AJAX site wasn't just about the APIs. It was about the way you thought about building these experiences. And he came up with this list. And it's really, I think it's really interesting because it's really boring. A progressive web app originates from a secure origin. Has to be on HTTPS. Loads while offline, even if it's just a basic kind of, oh, sorry, you can't access theguardian.com at the moment. And it references a web app manifest. And the web app manifest I'm not going to talk about because I don't have a huge amount of time. But that describes how your application should appear on the user's device. What should the bookmark be? What should it launch? Should it launch full screen? And those types of things. It's relatively simple. It's a manifest file. But when you go a little bit further, it's actually just about making sure your sites are responsive. They work across all different device formats, whether form factors. Instant, right? We think we can use Service Worker and a bunch of other technologies to deliver near instant load-in pages, right? First load still might take a little while, but every subsequent load, if you're in control of the network, you can make it instant to load, like 20, 30 milliseconds to have an experience on the page. It's reliable even in the presence of like intermittent data connectivity. Like if you're browsing through a page, it shouldn't just go, oh, you don't have internet connectivity, you can't go and view the next page. Like we should be able to be resilient to that. And it should be smooth, performant and engaging, right? Like the idea is that if you want to have it on the home screen or you want to have it push notifications, you should be able to do those types of things. But there is one core API that controls all of this. It's called the Service Worker, and I'm not going to go through too much of the Service Worker, but the idea behind Service Worker, and I encourage you all to look at this, is the idea is it introduces an app-like lifecycle to a website, right? Every single, when I say a site, I mean like all the pages that are contained inside that site. Traditionally, web pages, they have their own life cycle. They have like all the different events like DOM content loaded, unloaded, and a bunch of other things as well. But that's just for the single page load. The Service Worker itself kind of lives outside of the page and outside of the site, but can control everything in the site. And it can do a lot of things, right? Its goal is to be obviously to get installed and be activated. But once it's activated, its goal is to be asleep and then only respond to system-level events. And that's really interesting when you think about system-level events, is because what type of system-level events are there? Well, there's things like the Fetch API. You're in control of the network. Any network request that comes from your website, you can decide what to do with it. You push events, notifications. Notifications can live on your browser, on your device for 10, 20 minutes, 2 days, 2 weeks. You don't want your web page open for the entire time that notification is visible. So that's what happens is the notification gets raised, and then your Service Worker goes to sleep and only comes back on when the notification is clicked. The idea behind it is like it's active for a bit, then it goes back to idle at that point. And it's quite simple. I say it's quite simple to implement. I'm really massively generalizing at the moment. But the idea behind it is that you basically check to see if there's a Service Worker. You don't need a Service Worker to build a web app, but if you do, you can enhance it quite well. And then you register a small JavaScript file, the Service Worker file, and then it starts through its application lifecycle. And I'd say it's quite simple. Like you remember, like this is asynchronous, right? So you can still use your entire site in your page, but as you're using it and kind of navigating between all the pages, the Service Worker is sitting there going, OK, I'll install. That's like the traditional application install process. What do I need to be installed? In some cases, nothing, so that's fine. And in other cases, I need to make sure I've downloaded all the assets that I need for my application. And once those assets are downloaded, you store them in the cache, and then it's activated, and then it comes back out, and everything's ready. The way I like to think about it is this is a traditional model of the web, right? You enter your URL, you go to the server, renders something, sends it back, and it renders it inside the page. The Service Worker is interesting because it sits in between the browser and the network at this point. So the request will come through the Service Worker, and then you decide what to do. It's like a client-side proxy at this point. There's a lot of code in this slide. I'm really sorry for this. But the fetch event is the thing that gets fired whenever there's a network request generated from your web page, and you decide what to do. Respond from the cache, go out to the network, and then push it back in. Lots of different things. But the thing is, and the biggest point is, that the Service Worker puts you in direct control of how the offline experience works. And you can even do things like with analytics, where this is our analytics plugin, where analytics doesn't work offline, but if you want to make sure you have offline analytics, you can just queue up all the results. When you come back online, you send them back up through the Google Analytics. But because you're in control, you also get to do whatever pattern that you want for offline support. So you can support things like network first, where you will always go to the network and then cache the results as they come in. And then if you're offline, return the things from the cache instead. It kind of works. You can do the incremental cache. As you always serve from the cache, but as you go around the site, everything is cached as you go. You can do stale whilst revalidate, and this is what I use for my blog, is that everything is always returned from the cache, but at the same time, I always connect to the network and then update the cache, so the next time that you go to it, you've got the revalidated and updated content. But because, again, you are in control, you can do whatever you want, and you can follow any application programming model that you want as well. So we have this thing called the application shell. If you've been building native applications, it's probably very familiar. Is you have all the content and the assets and the structure of your application separate from the content, and you kind of cache all that and make sure that's like downloaded in the install phase, and then you kind of cache separately all the content as the user navigates around the site. So I like to think like this is the overall progressive web app experience. Is like the biggest thing for me is that we want to focus on reliability. If something is installed at the home screen, like the user shouldn't click on it and it shouldn't like give you the dinosaur. It should click on it and then at least the user gets an experience. Probably one of the biggest things for me. But then obviously we want to make things fast because you're in control of the network. You can be a lot more effective on that side of things. But obviously you want to focus on the user side performance as well. And then obviously you get things like engagement as well. Like if you want it to be on the home screen or you want push notifications, you get that package. And as a package, you can start to think about building these relatively compelling experiences. So for me, like service worker is to progressive web, service workers. Does that make sense? Anyway, like service workers are to progressive web apps as XML HTTP request was to AJAX. It's a technology in a broader suite of technologies that when you think about building these next generation experiences, you can start to apply them together. Like things like the app shell, like people are starting to use app shell as a concept just because like they're thinking about the progressive web app model, not that they're necessarily using service worker. And I think that's in itself is quite powerful. So that's the future, as in kind of the near future, and this is my hypothetical one. I've got lots of hypothetical things, right? But I do like to think of like more far future things about where the web is going to go. And I think what's going to happen in the near future is that we're going to start to see web experiences that like are of the web, hosted on the web, ephemeral, as in like you can use it, super lightweight experience. When you stop using it, it doesn't take up any more resources on your device. But you're never going to see a browser. It'll still be web content, but you won't see a browser. And I did this post, and I forgot to put the URL on properly, but the headless web is some of my thinkings around this. And the idea behind this is that there's different models for where the browser interaction happens. Is like you have the browser on the device, it's fine, and then you have all these connected things around you where the browser is starting to push out onto, things like watches, for instance. And then there's kind of other further kind of held devices as well. It's a relatively nebulous post, I'll be honest, but I want to show you some things where I think it makes a little bit more sense. So this is the first bit, is like we're kind of starting to slightly take the browser outside of its kind of local confines. And this is, the theory is you could build a podcast app or whatever it is, and then it'll be automatically hooked up to any kind of operating system level functionality, which could be expressed, in this case, via connectivity to your Android watch. Who has an Android watch? 3 people. Yes. But it could be connected to all these devices, and because you can control it from your watch, like the web page is still running on your phone technically, it's behind the scenes, but you might never, for a long time, actually have to interact with it. And I think there's going to be more and more of these kind of experiences kind of popping up and appearing. Then we have things like the physical web, where IoT devices, parking meters, actually, I saw some parking meters outside earlier on, which this would be good for. They can broadcast the URL. So rather than having to download an application and install it, well, you just kind of say, oh, this is the thing that's in front of me. I'll click and open the web page, and then I'll start interacting with it. And this is what's happening here. But again, this is still inside the browser in theory. But you get to the point of like the system-level discovery services for beacons can provide a lot more kind of context and a lot more actions. If you can describe in schema.org or some of the metadata the actions that can take place on your page, purchase this movie ticket, then that could be surfaced up in many different places, especially inside these inside the application picker that we saw at the start of this. Like you can get to the point where it's all powered by the web, the payment is taken by the web, but it's done by this very lightweight interaction that lives inside another application. And then you get things like notifications. The Guardian, this is in New York, they developed a really nice notification demo. It's a little mini application that only lives for the entirety of the time that you interact with the notification. You launch the experience to get notified about some interesting news. It sends you it, and then you go through and answer these questions. It gives you all the context, all the information that you need, and then at the end it says, do you want to go and visit the page? And yeah, okay, I'll go and visit the page. But by itself, it's a really nice, lightweight, headless application. And then when you think about these things on the device, what happens when it's on the server? Well, this is what, you probably all know Phantom.js and integrated into your continuous integration tests. Chrome is now doing headless Chrome and starting to build this. And this is where it gets quite interesting, because once you think about the types of things you can do on the server, like you can start to think about different types of applications that you can build out as well, which we don't even think about right now. One of them, and this isn't with headless Chrome, but it's a headless version of WebKit, something like PageSpeed Insights, right? It goes off, downloads a page, and then does deep inspection of all the JavaScript and all the network requests and everything that was generated by the page, which you wouldn't get just by parsing the page normally through a normal kind of web page parser. We get to this bit where the web browser on a server goes off, fetches the data, does analytics and information, like analysis on it, and then presents that in a relatively nice report. And then there's another one that we've worked on as well called Lighthouse. And if you speak to Paul Lewis or Adi Osmani or Paul Irish, they're actually working on this project right now. And the idea is that you can take things like Headless Chrome, integrate it into your continuous integration environment, and run any set of tests that you want to try and run on them. And again, because you can run these things on the server, you can do a huge amount of things off the back of that. So I do want to say, like, for me, I know I've talked about the mobile web. It's not just about mobile. It is a lot about like the web as a whole, desktop, phones, obviously for mobile, and any other kind of experiences that we're going to get. I do think our platform has become a lot more capable over the recent years, and all of the browser vendors are all catching up, and we're all starting to kind of get a level playing field so we can deliver compelling experiences. And it's a great meta platform, but as a whole ecosystem, we really do have to start focusing on how we build these next generation experiences. We need to concentrate on performance, we need to concentrate on user experience, and making sure if we want, the application is kind of this idea of a progressive web application where if the user wants to have it installed, they can have these applications installed. So that's me, I'm done, I'm a little bit over. Thank you very much.